Assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
This question says that coal, which is primarily carbon, can be converted to natural gas, primarily CH4, by the exothermic reaction, where carbon with hydrogen gas goes to methane, or CH4. And then it asks which disturbance favors CH4 at equilibrium, and it gives us all of these options here for different disturbances to the reaction. It's asking which is going to shift it towards the products. So let's just go down the list here and see what each of these would do. Adding more carbon to the reaction mixture. In this reaction, carbon is a solid, and we know that solids and liquids don't contribute to equilibrium constants, so therefore changing the amount of a solid or a liquid is not going to change the equilibrium of the reaction. So A is not an option. B, adding more H2 to the reaction mixture. Now, H2 is a gas, so this would change equilibrium. And since H2 is one of the reactants, if you add more reactants, you're going to shift the reaction to the opposite side. You're going to want to make this reaction make more product to balance back out. So adding more H2 would in fact shift the reaction towards products or towards CH4. So B would be a disturbance that favors CH4. C says raising the temperature of the reaction. This question tells us that this reaction is exothermic, so you can think of heat as a product. It's going to produce heat. If heat is a product and you're increasing the temperature, you're basically increasing the amount of product. And just as opposite to what happened in B, if you add more product, you're going to shift the reaction back towards reactants and go away from CH4. So raising the temperature of an exothermic reaction would not favor products or CH4. D, you lower the volume of the reaction mixture. The relationship here that is important is the relationship between volume and the number of moles of gas. On the reactant side, we have 2 moles of gas, and on the product side, we have 1 mole of gas. Volume and the number of moles are directly related. If you decrease the volume, you want fewer moles of gas. So if we're going to lower the volume of the reaction, we're going to shift this equilibrium towards the side that has the fewer number of moles of gas. And like we said, there's only 1 mole of CH4 over here, so reducing the volume would shift towards products for CH4. So D would favor CH4. E, adding a catalyst to the reaction mixture. Catalysts simply change the rate of a reaction, or the speed of the reaction, and that has nothing to do with the equilibrium. So E would not favor CH4. And F says adding neon gas to the reaction mixture. And I suppose they said neon because neon is a non-reactive gas. It's an inert gas, so it's not going to react with anything and shift it. But it is a gas, and we have to think about what effect adding a gas to reaction does. But when you add gas to a total reaction, you're going to add it to both the reactants and the products. So if you're adding it everywhere, you're not shifting the reaction in any particular direction. So just adding gases to reactions doesn't shift them. So F would also not change this. So the only things that would favor products would be adding more H2 here, or lowering the volume and shifting towards the side with a fewer number of moles of gas.